We are here for our second talk with Rémi Forax. We are going to talk about Valhalla. And Rémi is a Java champion, researcher, an open source contributor with a strong focus on JVM internals and stuff, programming languages and compilers. He's now an associate professor at Gustave Eiffel University in France, where he teaches and conducts research on Java optimizations and dynamic languages.
I will talk about Valhalla and the progress we have made in Valhalla. So let's start. First, don't believe what I'm saying. It's not that it's not true now. It's true now, but perhaps in 1 hour or in one day it will not be true anymore, because what I will demo is a prototype. So the Valhalla project was started in July 2014, more than 10 years ago. It's led by Brian Goetz, which is language Caesar of Java, and John Rose, which is basically the VM Caesar of Java. And the goal is, currently, if you take a look to Java, you have the primitive world, which is kind of nice, but quite of primitive too. And you have the class world, which is full of nice abstraction, construction, but they don't talk to each other. I don't know if you see there is no bridge in between them. And Valhalla is about trying to solve, at least build bridge, or better try to unify both worlds. So the first thing of Valhalla is to try to build no-cost abstraction. Usually you have things like a class month, and if you want performance, you don't want to use a class, but just an int. And if you have a class, it's better in terms of abstraction, but it costs you in terms of performance. What we want to create is something where you code using a class, and magically at runtime it works like an int. The other thing is that when Java was created, basically doing a pointer reference to a value or doing a plus was roughly the same time. But CPUs has changed a lot. We now have a lot of caches and things like this. And currently in Java, it's quite hard to have a flat representation of things. You can do it in C, because in C you can say I want a value using directly the value or using a pointer to the value, but you cannot do that in Java. By default, every object uses a value. So we want to try to be able to have a flat representation just because it's better in terms of performance. And the last thing is that currently, if you use primitive, primitive are like a second-class citizen in the language. An array of primitive is not an array of object, so you cannot abstract on an array of primitive. You cannot create an array list of int. It doesn't work with generics. For functional interface, you don't have a supplier of int, you have an int supplier. It's the same thing with stream and so on. So basically, you are using primitive because of performance, but your code is less clear in its intent than using a class. And you want basically the best of both worlds. So if we take a look of what is a class and what is a primitive, a class has an identity, which is for an instance, you have somewhere in memory where the instance is. So you can mutate fields because there is a place where the instance is. you can have fields, you can have methods, you can have interfaces. Your instances are nullable. You can initialize them with null. And you have encapsulation, private, public, and so on. On the other side, you have primitive. Primitive have no identity. The value 3, by example, the integer 3, have no location in memory. Basically, when you use a primitive, you don't use a pointer to it. You directly use the value, which what we call flatten on stack. You are using directly the value. It's the same on heap when you have a field. There is something not a lot of people knows, but when you have a long on a 32-bit CPUs, when you read it, you will read it twice, in two times, because you have a 32-bit CPUs and you have a 64-bit value. So you need 2 load and 2 stores, which means that if you have a problem with the concurrency, you can have 2 threads that when one thread seeing half part of the old value and half part of the new value. So you have no integrity of the value for long and double. And a primitive as a default value, which basically goes against encapsulation. Because basically encapsulation say, if you create something, you have to go to a constructor. And default value say you have a default value without going through a constructor. So what we want first is to introduce the notion of value classes, which is right in the middle between classes and primitive, which is, it works like classes when you define them, and it works like primitives, or more like primitives, when you run them. So a value classes has no identity because you want to use value directly, not use a pointer to the value, which means that all fields are to be final. Because of that, you cannot mutate something that doesn't exist in memory. They are flattened on stack, which means that if you are creating a method, basically you use it like a primitive in terms of runtime. They may be flattened on the heap. It's not that easy to flatten a value classes on heap. I will explain why, but mostly because they may be nullable too. They may have no integrity, but we want integrity by default because we want to be able to have value classes with encapsulation. So we want to offer a trade-off for the developer, which is basically choose if the developer wants something which is nullable, but it will not be flattened on heap. If they want a default value, but they will lose encapsulation. So the first thing, Valhalla is created in different stages. This is the first stages, which is described by the chap 401, sorry. And I will do a quick demo of it. So here we have a code. It describes a class complex. And if I go to the complex demo here, I can run the code and see. So I create 2 complex objects here, and I just print them and print if they are equals in between them. So my complex class here is just a record. So obviously when I run equals, it returns false because they are not in the same place in memory. But now with value class, I have a new keyword. So first you can see that IntelliJ mostly understands it. You have a partial support of it. And if you run the same example again, and we go here, you can see that equals now return true, because complex now, it's not a class anymore. It's not a class with an identity anymore. We call them identity class. It's a value class. And because it's a value class, what you have at the runtime is only the value of it. So if you ask for equality in between them, you will have the equality by comparing all the fields. And obviously, in this case, all the fields have the same value. So equals return true. We have a special problem with not a number. As usual, not a number is something awful. But if you take a look to this code, so I create a complex with not a number, and I create a complex here with not a number. I take the binary representation of it, and I change the last bit to be 1. So if I print it, it's not a number and not a number, because weirdly not a number has several representations, which means there is not one not a number. Not a number is a prefix for all the numbers. So if I just print it, I can see that I have 2 not a number, but if I use equals in between them, because they don't have exactly the same representation in binary, equals will return false. So basically equals compare all the fields bit by bit. Basically with a value class, you don't have the class in memory, which means you don't have the either of the class in memory. So if you ask for the identity hash code, which is basically the hash code which is stored inside the header of an object, here we are in trouble with value classes. So in this case, the identity hash code of an instance of a value class will be computed by hashing the value of the fields. That's why you get exactly the same value for both C1 and C2. And there is another thing, which is if you try to synchronize of a value on a value class, you can see that currently IntelliJ warns you about it. And if you try to run it, you will get an identity exception saying we are not able to synchronize on a value class, because synchronize require an address in memory. And with a value class, you don't have an address in memory. You only have the value directly. There is no pointer here. So currently you can download the Valhalla build, play with it. If you take the latest version of IntelliJ, IntelliJ recognize most of the thing, most of the value classes. So you can already write program to test things. And please, when you test these kind of things, go to the mailing list Valhalla-dev at opengdk.org and report what you're finding, and if it works correctly, if there is something which is you find weird or something like this. We want feedback at that point. So we have now see the difference between an identity object and a value object. basically equals equals is different, and identity hash code is different, and you cannot synchronize on them. Now the question is why using a value class? And I have a small code here. I will just show. This is a way to compute a Mandelbrot image. And I have the version using complex class. So first I will not declare it as a value class. So I have a complex class, and this is basically the algorithm you use. You can see that I'm using methods and so on. And if I run it, basically it will take 600 milliseconds to run. And if I do exactly the same, but I change for having a value classes, it will be just faster. Why it's faster? Because at runtime, instead of using a reference to a complex, you directly use the value. So basically at runtime, what you are running is this code, the one that use two double instead of using a complex. And so this is exactly the same code, and you can see that it's far harder to just read this code compared to using the complex abstraction. So that's basically it for now. So using a GMH to run a benchmark, you can see that if you use an identity class, so a class without value in front, the performance are not that great. But if you use value classes, the performance are strictly equivalent to the performance of using directly the two doubles. So if you have value classes, there is no point to write a code using primitives that will be harder to maintain. This is the abstraction for free. So this is a guarantee of a value classes. If you use the value classes inside a method or on the stack, you have exactly the same cost as using primitives. So we have seen that a value classes has a different equals equals that compare fields, a different identity hash code that hash all the fields. Synchronize doesn't work. Weak reference doesn't work because there is no reference, so you cannot create a weak reference on something which is not a reference. And both will throw an identity exception if you try to use them on value classes. A value classes is final because it's not mutable. It has no address in memory, so it cannot be mutated. So you cannot subclass them, but a value class can implement any interfaces. It can implement any abstract classes you want, so things like Java long object, number, or record. That's why we were able to create a value record, because value works for value classes and value record, basically. The way it works is so I want you to show you something, which is here. If I create a value classes, I must initialize the fields before calling super. The reason is if I were able to write this, so you may think it works, but if you run the compiler, it will not work, saying exactly that the field must be initialized before the call to super. And the reason is we want the value instance to be not mutable. But inside the constructor, you can see the mutation. So basically, by doing this, because in Java, this is only available at that point. Mm-hmm. So if you do the initialization before the call to super, you have no way to see the instance half initialized. So when you have value classes, basically if you write nothing, the compiler will automatically put the super at the end of the constructor, not at the beginning of the constructor, like an identity classes. And obviously you can make it explicit by just calling super at the right point. So this is a change in between the value classes and an identity classes. Obviously, we want to introduce the fact that you can initialize. Okay, so okay, it now works. So if I have an identity class which is not a value, it's written there, I can still declare that my fields are strict. Strict means they need to be initialized before the call to super. And this is important because it means that you will never have a problem of concurrency with them. Even if you have two threads, even if you start your thread inside the constructor, there will be no problem because you are only allowed to start it after the call to super. So currently, I'm using an annotation because this is a prototype. We don't know if we will add a new keyword or something else for it. If it's a value class, the compiler will add the strict for you. If it's not a value class, we have not decided on the syntax. Usually we prefer to decide about the semantics first and later talk about syntax when we know how it works, because it's easier to name something when you know exactly how it works. So this is basically how a value class works. It's mostly compatible with a class. In fact, you don't have to recompile. So in my demo, I have the class. I have two classes. I have the Mandelbrot set and the complex class. Technically, if I want to change complex to be a value class, I don't even have to recompile this. It will be optimized. The trick to do that is because the optimization are done by the JIT, not by the compiler. For the compiler, the class complex, if it's a value class, is just a bit saying it's a value class. Technically, it's the opposite. You don't have the bit saying it's an identity class. So, and at runtime, the VM will see that complex doesn't have the bit saying it's an identity class. And so the JIT will optimize it, which is really great because it means you don't have to recompile all your code. You can just put value where you want and all the code automatically will be optimized because the optimization is done by the JIT at runtime. So you don't have to recompile. So it's quite different from what you can have, by example, in C# with struct, where you need to recompile everything. So value class is fully backward and forward compatible with the identity class, which means that especially if you don't do a lot of equals and identity hash code and synchronize on object you don't know, apart those cases, it's fully backward and forward compatible. By forward compatible, I mean you can decide later that your value classes should be identity classes. Again, you just need to recompile these classes, not all the world that are using these classes. Okay, so this is a strict field initialization. A value class requires that all the fields are initialized before the call to super. And this is true for abstract classes too. So a value class can extend another class, like an abstract class, but in that case, this class must have its field be final and strict, so initialized before the call to super. One thing that is done by the prototype currently is that all the wrapper like Java long byte, Java long integer, Java long, and so on are now value classes. Which means that basically now when you use an integer at runtime, you don't pay the cost of the boxing at all. And this is true for optional. This is true for the result of map.off or set.off and so on. Because we have a backward and a forward compatibility, we can just declare old things that were created a long time ago. I think Java long integer was created for 1.1, so in 90 something. And now this is a value classes. And this is true for all the classes in Java time too, like month, year, local date time. Currently, if you use Java 25, the compiler will emit warning saying, be aware that those classes will be retrofit as value classes. So please don't try to do equals or identity hash code on them. Because the semantics will change slightly. So this is basically the current state of the implementation. Value classes can have fields, have no identities, they are flattened on stack, and they may have no integrity. They may be flattened on heap, they may be nullable, and currently we have no way to define that the value class is as a default value. We had a way, but we just remove it because it was not quite right. So I want to talk about those two things that are in progress. So this is a stage 2. It will be delivered later, which is for if you want to store value classes on heap in a field, we have a problem with null. Because if you want to flatten the thing and only use a primitive at runtime, we don't know how to represent null. It's another value. And there is no place to represent null. So that's the question. We have a value record complex. We have a complex box that stores a complex. Or we have an array of complex object, and we would like to optimize those at runtime and not use pointers, but use directly the value. It's quite easy if the size of the object is less than 64 bits. Because if it's less, by example here, it's 32 bits, so we have by example, 8 bits to have a Boolean saying it's null or not. And we can directly don't use a pointer for them. So this is an optimization which is not fully done currently in the prototype. We are still working on it. It's one of the roadblocks to have the value classes as a preview feature. And yeah, if it's less than 64 bits, it's quite. Why 64 bits? It's because if it's more than 64 bits, the CPU will have to do several loads or several store. And if you have multiple threads, you can see in between the things. And you don't want to be able to do that when you use object. If it's 64 bits, we want to introduce what we call an emotion, which is say directly as a user, this field will never be null. And the way to do it is just to use a bang. Yeah, it's a syntax which is familiar because you can find it in several languages. And so basically the idea is if you put a bang here, and even if you have here a 64 bits, the VM can optimize because the VM knows that this value will never be null. And it's exactly the same when you have an array. You can use directly an array. So at runtime, if you take a look to the array of my double bang, it will be like an array of double. But introducing those bang are not that easy in the language. This is something we are currently working on it. So the first thing is if you have a bang here, the field has to be initialized before the call to super. Again, the field has to be to have a default. It's not a default value, but it must have a value before you can read it. So it has to be. It can be changed later, but you have to have a value at the beginning. So before the call to super. For an array, we need a different syntax because we need a way to say this is the default value. So currently we don't have a great syntax for it. You have a to-do here. At some point we will need a real syntax for it. Currently, again, those are implemented using method, and you just pass a parameter. So I want to showcase this, and I have this benchmark. So it's a GMH benchmark, and I have an array of 1 million ints. I have an identity integer, which is not a value class, and I have an array of this thingy, and it's initialized with 0, 1, 2, 3, and so on. And I have a value classes, and if I want to create, as I said, there is no current syntax for it, but we have a special method when you say I want to create an array of value integer of that length, and it will be initialized with this value. And here you say it cannot be null, but it's still atomic, which means only one read, one write, not more than one. So this is the atomic part of it. And if you run this benchmark, I will not run it now, but if you run this benchmark, I have forgotten one part of it with it. You have this one, which is really great, which is you have a value integer box, which is a class that contains a value integer. And currently you don't use bang, it's not already implemented, so we have, for the prototype, a special annotation, which means basically bang, null restricted. You cannot put null in it. But if you try, the VM will throw a null pointer exception at runtime. And so if you run this benchmark, you can see that with a primitive, it takes some time. If it's an identity, it's slower because you have to dereference all pointers. If it's an array of null restricted value classes, it's the same times an array as an array of primitives. And if it's an array of value box that contains, each value box contains a value, which inside contains a primitive, there is no cost at all, because you're able to declare there is no null, so it can be stored as a primitive at runtime, basically, which is kind of great. So we need to add a null state analysis to the language. Currently, we will have something which is quite similar to Kotlin, which is basically you have 3 states. We have 3 states and a half because of the parametric thingy, the E or T inside the language that behave weirdly. But if we don't talk about them, basically when you have a type, it can be not null, it can be maybe null, or which means you can store null in it, and it's unspecified in you are interacting with a code that doesn't have those information in it. Old code, or currently all the code written in Java. And basically the null state analysis is, in Java you have a definite assignment analysis that checks that all local variables are assigned before being read. And this analysis can be retrofit to do the null state analysis, which is kind of cool, which means that it will not slow the compiler. It's done in the same path. And so it's not null if the expression is known to be not null. By example, if you do new something, you know that the result is not null. It's not null if above there is a null check or a call to a field or a method that will throw null pointer. So you know that below it's not null. Otherwise, it may be null in new code or unspecified in old code. Basically, unspecified is just there to avoid to have a lot of warnings when you interact with, let's call it legacy code. Now, is it like in Kotlin? Sadly, no. No. First, the Kotlin semantics say the question mark and so in Kotlin, basically you only have question mark and it's non-null by default. But this is true in all cases, but inside a constructor. But we can do exactly the same thing in Java, because we want to be sure that at any point, even inside a constructor, the field is never null, because we want to be able to flat it and to use primitive instead of a pointer. So basically, Kotlin erases the notion of is it null or not. It's just a type checking and it's not something at runtime. But here we want to do it at runtime. So we have to be sure that it will never be null, even inside the constructor. That's the first problem, or why it's not like Kotlin. The other one is Kotlin starts by saying it's not null by default. Since the version 1.0 of Kotlin, in Java we don't have that. We have backward compatibility, which means that by default it has to be nullable, which means that if we introduce an annotation, it will be bang, not the other side. Otherwise, previous code will not compile anymore, which is not a good idea. So the nullness analysis only produce warning, because otherwise you will not be able to call legacy code, basically. So only warning and null pointer at runtime, which means if you try to store null inside a complex bang, you will have more null pointer, which is kind of weird, because we want to be sure at runtime that there will be never a null. We have several ideas to try to make it great, to avoid to have a kind of a flag day of rewriting all the dependencies. So we want to try to have only 2 states instead of 3, which means that you only have to put bang, and all the other are question mark, which is inside a file. If you put a bang, everything become a question mark at the same times. And it's only unspecified if you call another class that was not written using bang or question mark. That's the first thing, which is the compiler have 3 states, but from the user point of view, you only see two states. The other one is something that JSpecify does. I don't know if you know, but it's a set of annotation you can use in Java. And currently in JSpecify, you don't specify the nullness on local variable. The compiler will infer them. And we may try to do that too. So in that case, you will only have to put bang on the signature of the method and on fields, but not everywhere else. So it will limit the number of bang that you will have to make. Because we cannot do like Kotlin and saying it's bang by default. Obviously, if it's bang by default, you write less question mark. But because it's in Java, we have to use bang. We try to reduce the number of bang that people will have to use. So yeah, having the local, not having to use bang for local variable may simplify the code, and it's also great for migration, which means that if you have a dependency to a legacy code and this legacy code now use bang, they will flow automatically to your code. You don't have to recompile them, which is again a quite nice feature. So this is the end for stage 2. We are actively working on stage 2. So a lot of air quotes. And it's worst for the next stage. The next stage is stage 3, which is, if you take a look to a value class and a primitive, you can see that basically a primitive is a subset of a value classes. So we don't need primitive anymore. We don't want to have a free kind of class of type. We just only want 2, and basically retrofit all primitive to be value classes. Primitive being a special cases of value classes. So no primitive anymore. Yes. What we should do for that, basically what we want is that int and integer bang to be equivalent. Sadly, we cannot do it fully because in the bytecode, those are 2 different representations. If you load an int, the small int, it's eload. If you load an object like integer.bang, it'saload. So it's not exactly, the code is not fully compatible, but we can try to soften the edges. So basically, we are thinking of things like be able to call a method on an int, being able to call a method directly on a literal. This require works because if the currently if the parser see 3 dot, it think it's a float so, or a double. So we need to change the parser, but it seems possible. we want to make new array of list being the equivalent of integer.bong. Because we have erasure, it's really easy. This one is really easy. At runtime, we want to be able to take an array of int and seeing it an array of integer bong. It requires some VM magic, but it seems possible. And we want to be able to override a method m that return an integer with a method m that return an int. So we will try to fix as many inconsistency we can. For beginners, when stage 3 will be released, there will be no difference between an integer bong and an int. That's basically the idea. So we need a way to specify how to define a default value on a value classes. This is the syntax we may use, which is basically you have an implicit constructor, which means it can have a default value. The default value is all the fields are zeros, because we can do a lot of optimization with that. So this is currently not supported by the prototype. It's in a later stage. And obviously, if you have value classes like myInteger, which have a default value, you don't have to initialize before the super, because it can take the default value in that case. And again, when you create an array of an integer bong, myInteger being a value classes with a default value, you don't need to provide the default value for the array in that case. Currently in the prototype, you can also say I'm okay with several load or several store. Currently, it's done by implementing an interface. We may change in the future. It's just how this is done, which means that even if you have a lot of fields, you can say, I want to see it as a value classes. There is a kind of a limit, which is because when you do an equals and you have a value classes, you have to copy all the fields. So at some point, if you have too many fields, it doesn't make sense to declare it as a value classes, because the traffic for loading and storing the thing will be too much compared to using a pointer, even if the representation is more compact. But currently we trust the user on that. And this is basically my last slide of how we see Valhalla. So the first thing we want to introduce is the value keyword. We are missing some optimization, but once they are done, it will be released as a preview feature. Next will come the bong and question mark things, so adding nullness for fields and method parameters. Then we will try to retrofit primitive types and maybe add operator overloading, but only for value classes that have a default value, where it makes sense basically to have operator overloading. And the last part, which is there is something embarrassing currently, which is being a value classes or not, it's something that the VM check at runtime. But if you have a list of complex at runtime, you have no complex anymore, because generic are erased. So the VM has no knowledge that your array of object is exactly an array of complex, so an array of value classes, which means that currently, if you use collections, you will not have the optimization that you have if you are using an array. So we need to introduce specialized generics, which is basically, we still want a generic with erasure for backward compatibility, but have a way to propagate the type so the JIT can see the type at runtime and optimize it. Because being a value type or not is something that the VM only knows at runtime and not before. And that's all for me.
Thank you. That was actually, I really loved the way you explained all the concepts, because I haven't heard about Valhalla for years, and now I actually managed to recall all the things I've heard before. And all the questions, like all the first questions, were related to when.
And it's when it's ready.
Yeah.
So the thing is, value classes, especially if you just put value in front of it, is an optimization in terms of performance.
Yep.
If we release something where there is no optimization, there is no point to use value classes.
Sense.
So until we have all the optimizations we want inside the prototype, it will not be released. But once we have them, and we have most of them currently, then it will be released.
Yeah, so that was my...
So the answer is when it's ready.
That would be my second part of the question, on more like, because I know these questions are kind of vague, because we don't know. But the question would be, how do you feel the progress? Like, are you progressing like, with a well-paced manner?
I think on the first two items, so just value and the bang things, we have progressed a lot.
So does it mean that the Valhalla will eventually be released in in milestones?
Yes,
like
yes,
in parts?
it will be. That's why we have stage 1 and stage 2 and so on.
So these stages are, it's like this way it will be delivered, shipped, and so on.
Exactly.
That's great to hear.
For 3 and 4, I'm not sure.
Of course.
Of the order, but 1 and 2.
Okay, that's great to hear. I mean, like, we can expect it someday.
Yes.
Yes. I mean, like, in terms of times when someday is somewhere we can expect. Okay, got it. Because the next one was, so the value classes come with Java 25, right? And I'm not sure.
And no, it doesn't come with 25. You can download a build called the Valhalla build that works, which is 25 modified. So I think the build is not public yet.
Okay, got
so
it.
currently you need to go to the repository. So github.com/openjdk/Valhalla and build from the sources. As I say, IntelliJ has started to provide basic support of it, which is really, really great. There is no red anymore when you write value in front of a class.
That's actually what we are trying to do during latest times. We want to support Java before it is released in public. So basically our goal is to have everything for our users before it becomes like production grade. So
when it's the one.
Okay, the next question is about Scala. So Valhalla value class can provide can they provide a way to implement Scala case class?
So case classes are more like records. So it's something which is separated. You can have a record and you can have a value record. So I don't know well what are the plan of the Scala people, but usually when you have new feature in Java, because it's not a feature in Java, it's a feature of the VM, they are quite quick to adopt it. So I think you will have some kind of value case class.
Okay.
I think in Scala there is already, I think it's like in Kotlin, you already have a value classes, but it's limited to one field.
Probably. I am better with Java than with Kotlin because like...
I think that both in the case of Kotlin and Scala, they have already thought about it. So I think the transition will be kind of seamless like in Java.
Okay, got it. Then there is one question about your presentation, and it would be great to have slides here because there was a int m override for integer m.
Yes.
So is it integer bonk m, or like we would be able to override
both?
Both. Okay.
Yeah. When you override something, as a compiler is a kind of lenient and lets you to forget the bang, which means that you can have the main issue is when you have two libraries. One is written with bang and one is not written with bang. If you are in Python,
yeah, okay.
By example, you had to wait until your dependency were in Python 3 before you moving in Python 3, and we don't want that. So we are, for overriding, we are more lenient, which means that you can, in your code that implements an interface from an API, use bang, even if the API don't use bang yet.
Okay, got it. Got it. And we actually have 40 seconds. The question, I guess we will make it. Will primitives ever be nullable?
It's Java long integer is a nullable primitive of int.
So we already have it. And at this point, I guess I just want to thank you so much because I enjoyed the talk. I hope our viewers also enjoyed the talk. And as I say, always, drop your like here because the talk was amazing, the stream is amazing, and we are amazing, and you are amazing. And subscribe to us in our social media.